Hi team, welcome to Wiggins Maths. In this video we're going to be changing parametric equations into Cartesian form using trigonometric functions. Okay, so this one has quite a few examples, lots of different little permutations to consider. Now because I want the sole focus of this to be turning into Cartesian form, I'm not going to be talking about the domain and the range in this video. Okay, so let's get cracking. So, example number 1. This is where they contain the same trig function. Now, these are the easiest ones to work with. When it comes to trig functions in parametric, however, always start with the same point, and that is make the trig function the subject. So I've made the trig function the subject here for x. And I've made the trig function the subject for y. Now, since these are both equal to cos t, they must be equal to each other. And there we have it. I mean, we could do a little bit more with it. You know, I could multiply both sides by 8 and then subtract 5 to make y the subject. You know, the question might say you leave your answer in the form y equals f of x. But I've written this as a Cartesian equation now. So that's the simplest form. Okay, also worth pointing out, if they have the same trig function but one is a power, the same rule applies. So let's make the trig function the subject. Okay, now I could make cot t the subject in this one, but now I have it written here, I can substitute it into here straight away. So let's do that. Now, unfortunately this time, I can't really leave it in this form. It's a little bit messy, isn't it? So let's just tidy this up ever so slightly. So that's going to give me 25x squared. So that's going to give me and then we should simplify that as well. Okay, so now it's in the form y equals f of x. Next. Okay, so this time they're not the same, so we're going to have to do a little bit of extra work. So let's make the trig functions the subject. Okay, what do you know about sec and cos? They are the reciprocal of one another. So what we can do here is I can change that top equation by taking the reciprocal of both sides. And now we have it written in terms of cosine for both expressions. So now I can write this is true. Okay, so what I could have done is I could have then substituted this straight into here, but this is also the same function. Okay, sometimes it'd be easier to substitute this straight into here. Sometimes you can write it like this. It doesn't really matter. So let's just finally tidy this up then, shall we? So that's going to be 40 over x subtract 2 and then subtract 5. And that's fine to leave it like that. Okay, what about this time? So, step 1, let's make the trig functions the subject. Okay, so what do I know about sine and cos, or what identities do I know that contain sine and cos? Well, we've got the Pythagorean identity, don't we? So we know that sine squared t plus cos squared t is equal to 1. So I can do exactly that. I square both sides and then square both sides. I can now write down this. And we're done. And hopefully we can see that this is, this is related to a circle, isn't it? Okay. And that doesn't surprise us, or shouldn't surprise us, that we end up with something that's related to a circle or an ellipse. Okay, what about this time? Again, okay, so what do we have this time? Well, I don't know a specific link between cot and sine, or do I? Well, let's write down those identities again. So we've got sine squared t plus cos squared t equals 1. And from that we can get 1 plus cot squared t equals cosec squared t. Now if we look really carefully, we've got a cot and a cosec. Now cosec is the reciprocal of sine, so I can rewrite this term here like that. And I can write this like this. And now I can write out that. Whew. And it looks a little bit nasty, but that's absolutely fine. Okay. From this we can say things like y cannot be equal to 1, for example. Otherwise this simply will not work. But yeah, we've managed to change this into Cartesian form. It's a little bit messy, but I have y in terms of x. Okay, what about this time? So let's make the trig function the subject and the trig function the subject. Okay, is there a relationship between cot and cosine? Well, let's write down our identities again. Okay, and then we've got 1 plus cot squared t equals cosec squared t, and then we've got tan squared t plus 1 equals sec squared t. Now if we look really carefully here, cot can be rewritten as tan, cos can be rewritten as sec. So this time I'm going to take the reciprocal of both of these functions. So 6 over x subtract 1 squared, that's tan squared, reciprocal becomes tan, add 1 equals reciprocal of this is 2 over y plus 3, so that is sec, and then if I square it we end up with that. So we've done that as well. Okay, that's not too bad. Okay, so slightly more challenging now, and I have put a restriction in here and I'll talk about that in a moment, but this is a problem where we have multiple trig functions. Okay, so I could start off by writing this. And that's absolutely true. I've replaced sine t with x, but I still have cos in terms of t, and a Cartesian equation only contains y and x. So, what do I know? It's the same old story, guys. And sine t is x, so that is x squared plus cos squared t equals 1. So therefore cos squared t equals 1 subtract x squared. And then cos t is the square root of 1 subtract x squared. Now, some of you might be thinking, why do I not put a plus or minus in here? Well, you'll find in these types of questions that the restriction here will tell us that we only take the positive root, because it's between 0 and pi over 2. That is the quadrant where all trig functions are positive. Okay, so we might have to look out for that a little bit more. So there we are. It is now in Cartesian form. So a little trickier, that one. Okay, what about this one? Again, you'll notice there's that restriction, but we have a compound angle. So logic dictates that the first thing I'm going to do is write this out from the formula book. Incorrectly, it seems. Let's have another go, shall we? Okay, that's a little bit better. And then let's tidy this up ever so slightly. So x equals, well, cos pi is -1. And then sine pi is 0. Okay, so x is equal to negative sine t, and we seem to be no closer to what we want to find. However, I now have something written in terms of sine, something written in terms of cosine. I can use the Pythagorean identity. Okay, so x squared is equal to sine squared. -1 multiplied by -1 is +1, and y over 7 squared equals cos squared t. Add them together equals 1. Whew. I could rewrite this as y squared over 49 if I wanted to. So there we have it for that one. Okay, and then this one we have a double angle. Again, we have this restriction. Sine 2t, we like sine 2t because there's only one way of writing it, so let's do that. And then hopefully we can see how this is similar to one we did a couple of examples ago, in that I can now replace this cos t with x over 3. And then I need to find out what sine t is. So again, Pythagorean identity. So 1 subtract x over 3 squared square rooted is equal to sine t, and then we can rewrite it out like this. Okay, and that x could be in front of the 2/3. You know, it's a little bit messy. It is a little bit messy, but it's not too bad once again. Okay. And then last example you'll be glad to hear, we've got double angle, but this time cosine. Now, cosine 2t is the awkward one because it can be written in 3 different ways. There is no harm in writing out all 3. This first one is directly from the formula booklet. Okay, I've done it as cos a plus a. And then this could be written as 2 cos squared t subtract 1, or 1 subtract 2 sine squared t. Now, you need to look at these and then determine which one you think is the most useful. So this one It's got cos and sine in it, not that useful. This one has just got cos in it, really not that useful. This one has just got sine in it, bingo. So now we can actually start to work with this a little bit more. So y is equal to 2 lots of 1 subtract 2 sine squared t, subtract 1. Let's expand that and tidy it up. Lovely. I can rewrite this as x over 4 equals sine t. Square both sides and then substitute it in. And I could tidy this up again here. So that becomes x squared over 4. And there we have it, guys. So that was a little crash course in parametric Cartesian using trigs. So just a little checklist here for us. So were they the same function? Are they reciprocal of one another? Can we use sine squared plus cos squared equals 1 or the other two versions of that? Do the reciprocals of them make the Pythagorean identity? Do I take the reciprocal of 1 and then we have 1, or do I need to take the reciprocal of both and then we have a Pythagorean identity? Are there multiple trig functions? So is it sine x cos x? Can I replace cos x with something from the Pythagorean identity? Are there compound angles? Well, if there are, expand it. Figure out what it is in terms of single functions. And finally, are there double angles there? If it's sine 2x, lovely. It's only one way of writing it. If it's cos 2x, well, let's think about how many different ways we can write it and which of those are useful. Okay, so as always, watching this video doesn't mean you'll instantly be able to do it. You need to practice. That is the key to success, and the more you practice, the more successful you will become. And always, amateurs call it genius, masters call it practice.